Hi guys, Buildzoid here, and today we are going to be taking a look at the RX 5700 XT TUF EVO PCB from ASUS. So before we get into this, the pictures are from Tech Power Up, so huge thank you to them for providing, high-res PCB pictures in their reviews. If you want if you want an actual review of the card, go check out the link to Tech Power Up's review down in the description below. That's where I got the pictures from, and, their reviews are very in-depth. They cover all kinds of stuff, so I strongly recommend you actually, if you're actually interested in the card, go check the link in the description. Anyway, if all you care about is the power delivery on this, then yeah, you can just watch this video. So let's get into it. The reason I'm actually doing this card is because... Oh, and I have dynamics on. Okay, I don't want dynamics on. There we go. Yeah, so the reason we're taking a look at this card is very, very simple. ASUS has all these different... labels on the card for the various voltages, which I just think is really neat. And so, yeah, that's why I wanted to take a look at that's like the first thing that caught my attention with this PCB. It also helps that the PCB itself is a pretty good, custom design for what is not one of the, well, I'm not sure how much the card costs, but it's not meant to be the most expensive of the 5700 XTs. That would be the Strix, and, well, that one has a very nice PCB, but it also costs almost as much as, a 2070 Super last I checked, so, yeah, that doesn't make a lot of sense. But anyway, so they have labeled all of the different voltages, like 5-volt VESA, which I had no idea is a thing, but yeah, that's for, display outputs. We've got 3.3 volts from your PCIe slot labeled, 12 volts labeled, 1.8 volts labeled. This rail, which I'm pretty sure I've been incorrectly calling 0.95 volts or 0.85 volts. Yeah, that's actually 0.75 volts. That should be, well, I would assume that is the equivalent of the old 0.95 volts rail that you'd have on some of the 28 nanometer GPUs. So yeah, it's just cool to see it labeled SoC rail, which I actually have. The AMD GPUs have been steadily getting more and more voltages. It's actually kind of ridiculous. It used to be that you had vCore, VDDCI, VMEM, and then minor rails 1.8 volts, 0.95 volts, that kind of thing. And now it's well, now you also have SoC and VPP and all of that. So VMEM is labeled, memory controller is labeled. So yeah, this always existed, the 5-volt VESA, but whatever. So yeah, I just think it's really cool that the card comes with all the different voltages labeled. Yeah, because if you were doing, if you were going to mod the card, this makes your life a little bit easier. So I think that's pretty neat. And then, it helps that the VR, the power delivery itself is not actually, is pretty good. So this right here is the vCore and VSOC VRMs. So VSOC is, of course, that bottom part. Is that? No, that says L. Wait, no. That's not labeled. Oh, that's a shame. It's I guess that's... no, I have no idea what... this kind of looks like a thermistor, but it also could be a cap. So I'm not entirely sure. Anyway, so the top part of that is, of course, vCore, and that's a 7-phase, which is a pretty... you can get 5700 XTs with less phases than that, so I'm actually a fan of that. And then down here, we have the SoC rail, and that is, of course, a single phase. So the way this whole thing is controlled is this chip right over here, which that is an IR35217. Does it have a B at the end? No, I'm pretty sure it's just a 35217. Anyway, this is an up to 8-phase controller. Here it's running in a 7+1 phase configuration, so all of the phases are very real, which is pretty neat. And then for the actual power stages, and this is also pretty much the best voltage controller you can use on an AMD GPU these days. What's also kind of neat is ASUS actually gives you the pinout to hook up to the I2C interface of the chip. So if you had the Infineon USB 005 dongle, you can actually just kind of take manual control of the chip. Though I'm not sure if you'll be able to disconnect it from the cut off GPU core communications and still keep this. Though I guess you could trace that out and then cut off the traces and then solder your own jumpers directly. But anyway, so yeah, we have this, so you can actually talk to the controller, which is pretty neat. yeah, so that's there. And then for the actual power stages, what we're looking at is for VCore, because there's two different power stages that ASUS is using on this card. For VCore, we've got SIC 620As, which are pretty neat. These are 60 amp DR MOS components, and they're not as dumb as, they're not the bare minimum of DR MOS components, where it's like you have your driver, your two MOSFETs, and that's it. These also integrate some basic thermal protections, and that's actually kind of it. So... yeah, so these are a little bit smarter, and they are actually pretty damn efficient. So with the 7-phase here, we actually have a rather nice VCore VRM, and the efficiencies we're looking at are as follows. So for 1.2 volts output voltage, oh, and what's also neat is the A here is a that's the 3.3 volt variant of these chips, which means there's no extra like 5-volt voltage regulator to power the VRM, because a lot of the time if you have power stages, you need a 5-volt rail to power the actual power stages. Well, you don't need that with these. These run off of straight 3.3 volts, so we can just grab that from the PCIe slot. Anyway, so 1.2 volts output voltage, 500 kilohertz switching frequency, and of course the 3.3 volts drive voltage. You'd be looking at the following efficiencies. For 200 amps output, the VRM should produce about 22 watts of heat, which you know, consider like GPUs have a huge advantage over motherboards in that the VRM gets forced airflow, so it's not as much of a problem to cool the heat output of the power delivery, but 22 watts is also not that high for 200 amps output, so that's a nice efficient VRM right there. Then going up to 250 amps output, we get 33 watts of heat, which, like, again, with enough airflow, this is completely coolable. 300 amps, you're looking at about 45 watts of heat, and now it's starting to get kind of borderline. And at the same time, I'm pretty sure you can't get a Navi, well, you can't get a 5700 XT to pull 300 amps average current on any kind of like ambient cooling. So it's not really a concern. Like, this is not something you'd be able to do with the card. So the VRM getting kind of hot, like getting pretty damn hot when you do that, doesn't really matter, because you'd be on like liquid nitrogen or something. And if you're on liquid nitrogen, like, the benchmarks don't last that long, and the whole, like, not overheating for 2 minutes is a lot easier than not overheating for 2 hours. So that's kind of the thing there. So yeah, and then 350 amps, which is actually, I think these do spec out the datasheet all the way to 60 amps, which is not that common. Like, a lot of the 60 amp power stages will end at 55 amps on the datasheet, but anyway, like, already 300 amps is not really a practical consideration. 350 amps even less so, but hey, maybe if you're really pushing it on sub-zero cooling, you might get to 350 amps output, and at that point the VRM will produce about 63 watts of heat, which is a lot. But it is still coolable if you just force enough airflow into it, like throw enough airflow at the problem. The problem is fans that produce that much airflow get very loud. So yeah, but still, for a, you know, like, lower cost 5700 XT, this is actually not a bad VRM, because you get a lot of cards which are like a 6-phase with 50 amp with 50 amp power stages, or 7-phase with 50 amp power stages. I think there's even a couple of cards with like 45 amp parts. So this is actually a very, like, a rather nice VCore VRM. So I like it. And the fact that also you have the voltage labels, like, I think this is overall a pretty neat card. Anyway, for the SoC VRM, we are looking at a SIC 632A DR MOS, 50 amp DR MOS component, about as smart as the SIC 620As. Yeah, well, the SoC rail doesn't need to push anywhere near as much current as the VCore, so you don't really need to worry about this. This is on par with what you'd get on any other RX 5700X XT. Actually, some cards will use like a 45 amp part instead of a 50, but, you know, basically the same thing. Anyway, so that's kind of that. Then over here, what I like, now we get into the neat things. Like, this is our 0.75 volts regulator, which we know thanks to ASUS actually labeling it, so I'm a big fan of that. This should be the 1.8 volts. I'm not 100% certain on it because, like, we do have this power plane running over here, and then there's that voltage read point on the other side of the card labeled 1.8 volts. And honestly, this looks a little, like, really substantial for what as... Like, my understanding historically has been that 1.8 volts is primarily for the BIOS chips that the GPU uses. You use 1.8 volt BIOS chips on GPUs. They do go up to, I think, like, it's 1.8 to 2.5 or something. Like, there's a voltage range on them, and normally you run them with 1.8 volts. But this is quite a bit more substantial than that. So I'm not sure, like, this probably actually powers something internal to the GPU as well. I'm just not sure what that would be. But yeah, that could be a, like, these are, like, the minor rails like this are, for ambient overclocking, they generally don't do anything, but if you were maybe pushing the card on sub-zero, a lot of the time these sort of minor voltages can help with fixing various cold issues where a lot of the time you have issues like card stop, like, a lot of the time you can fix things like the card black screening if it gets too cold, so yeah, it's just neat that ASUS has these, like, clearly labeled, so they're much easier to track down. If you were interested in modding the card for running it sub-zero, and then again, like, you actually have a pretty decent VCore VRM. Other than that, we've got the VDDCI VRM over here, and of course VMEM up here. Both of those are controlled. So VMEM is a two-phase, which is the norm for a 5700 XT. I'm not a fan of what ASUS did with the layout. So normally, and this is actually the biggest reason why you wouldn't want to run this card on LN2, is this cap right here. It really, like, that's a problem. Luckily, we do have pads for, you know, like, SMD capacitors right here. This inductor could also be an issue, but these sap chokes are generally somewhat low profile, so depending on your LN2 pot, you might actually clear that. You won't clear the capacitor, so this is annoying. But you could just, you know, take that off and replace it with a pair of SMD capacitors. But the thing I'm not a fan of with this layout is not so much that we have a cap here. That's actually... Like, that's not as bad as what you'd normally get on a 5700 XT, where you basically have a cap sitting over here and right here, and is like, great, that's exactly where we needed capacitors. But the thing I'm not a fan of is, I assume the reason why 5700 XTs normally come with a memory VRM where you have one phase right here and one phase right here is it improves the power distribution across the GDDR6 memory chips, because you have, you know, you have power coming in over here and you have power coming in over here, and so you don't have, like, a far away chip, or at least the furthest away chip is less far away from the VRM than it would normally be, and that should just lead to somewhat better voltage distribution across the power plane, because over long distances you start losing power, and so, like, one memory chip might be at, like, GDDR6 runs on 1.35 volts, I think. So, or 1.2. I'm not sure right now. I don't really care. Either way, you could have, like, one chip at 1.35 volts, and then the chip on the other side of the PCB, the chip furthest away from the actual memory VRM, that might be sitting at, like, 1.3 volts, which is like, well, that's not ideal, especially if the chips actually scale with memory voltage. Then you have one chip that's getting 50 millivolts more than another chip, and that means that chip that's getting 50 millivolts less, that is the one that's probably holding back your overall memory overclock. And so, yeah, I'm not really a fan of the fact that ASUS basically went and sort of screwed up the power distribution, right? Like, all of it now comes from over here, and so now you do have a far away chip, it's that one. So, yeah, not really a fan of this redesign, but there's more 5700 XTs that do this, and, like, if I had to guess, this probably doesn't make that much of a difference, but, you know, a couple megahertz of GDDR6 clock probably... Like, you could lose a couple megahertz worth of GDDR6 clock depending on how exactly this is implemented. You know, it could also be that they're compensating for the rearranged VRM in some way that I can't see, but generally you want your power delivery as close to the thing you're trying to power as possible. So, yeah, not really a fan of the fact that they moved it up here. VDDCI is in the same place as any other card, so there's not really I don't really see a problem with that. The controller for both VMEM and VDDCI is this chip right over here, which I already, you know, put an X on, and that is an IR3567B. And what's really cool about this is a actually really high-end controller. Like, this is what you'd normally get on a 290X. and also Hawaii, and well, Hawaii's 290X, Fiji would also use this controller. So this is a really nice high-end up to like 6+2 phase, up to 6+2 phase controller. And here they're just running it as a 2+1. So yeah, that's pretty neat. And I think, well, actually, not I think, like definitely if you just connect over here, you'll be able to talk to both of these. The biggest problem is if I was trying to manually take control of the controllers, you would probably want to disconnect them from talking to the GPU core, because a lot of the time that can cause all kinds of nasty conflicts. And the other thing is the whole point, in my opinion, of trying to talk directly to the controller would be to like make the core think that things are like things aren't actually, like you're not actually doing anything while you're changing voltages and all kinds of things. So the core has no idea that it's pulling way more power than it's supposed to be pulling, which is like the best way to do any kind of overclocking, right? So yeah. Anyway, that's the control scheme here. So that's pretty, pretty cool. Like ASUS uses the high-end controllers everywhere. Though honestly, actually for modding, the NCP81022 would be easier to work with, because that chip is dumber. Like there's just a bunch of resistors to set a lot of the functionality, whereas these are fully digital. So you do have to actually you have to configure the registers. You can't just rip off a couple resistors to get overcurrent disabled and that kind of thing. Like you can't do that. Anyway, from VMEM and VDDCI in terms of the actual power stages is just more SIC. You can even read them here. SIC 632As, which is the norm for a 5700XT in terms of like having these chips. So yeah, nothing really that special there. And yeah, so really so overall, it's not really like a super special card, but it's just nice that, you've got a nice V-core. You've got the norm for everything else. The voltages are labeled. And I will say, like, ASUS does make it rather easy to, like, mod the card a bit more, right? Like, we've got all these empty pads for extra SMD capacitors. I'm a fan of these right here, though, again, it's like, I wonder if they have these over here specifically because the memory VRM ended up here. Because a lot of the time, the way these would be distributed would be, like, you'd have one on either side of the memory, but again, like this could be some of the workaround for like, well, now all of our power is coming in over here, so now we need sort of power storage like nearer to this memory chip over here. So yeah, it's a pretty neat card, and I'm just a huge fan of the fact that all the different voltages are labeled. And what else is there? Oh, you also get little LEDs to indicate if the 8 pins are plugged in. Unfortunately, there's no dual BIOS functionality on this, which is a bit of a shame in my opinion. But yeah, I like it. Like it's a pretty neat little 5700 XT PCB. There's not really any kind of like massive corner cutting that I can see. And for the actual capacitors that ASUS did populate, so not the very expensive ball, like I'm like, I really wish they had included all these expensive SMD aluminum polymers on the back, or tantalums or whatever, but like, yeah, no, they didn't. But these caps that they do have, these are all just APAC, which very common capacitor manufacturer, aluminum polymers. These are cans, but with the like package adapted to SMT. And like that doesn't actually give them any kind of performance advantage. It's just like it makes it possible for ASUS to run, like I'm pretty sure, well, yeah, I'm pretty sure they do this for basically all of their cards now, is that ASUS has fully automated production lines, as in there's there's no through-hole components except for like display connectors and power connectors. And I do believe there's a way to like, I'm pretty sure machines are capable of doing those as well. So yeah, that's what part of the reason why you see ASUS use all SMD, like SMT capacitors like this, but then even then still use like, not actually use the molded polymers, which are much more expensive and better. But yeah, so, and these are all rated for 5,000 hours at 105 degrees. So, the norm for capacitors on a GPU. Well, actually, like if you went with the cheapest, well, I'm not sure I've seen a 5700 XT using any 2,000 hours rated caps, but it used to be the norm that like the default capacitors would be 2,000 hours or 2,500 hours, or yeah, you'd have 2,000 hours as the as the standard capacitors that you'd get, and then the higher end cards would give you like 5K and 10K, but the endurance rating does not actually necessarily mean that they have better overall performance, but as in like ESR or ESL, but you can get like 5K is not a rating that's particularly like once you get into the like if you want the really high endurance capacitors, you generally have to sacrifice some ESR or ESL for it, but 5,000 hours you can still have good ESR and ESL ratings on the caps. So yeah, that's the 5700 XT TUF EVO. It's a pretty neat little 5700 XT in my opinion. And yeah, so thank you to Tech Power Up for the pictures, and that's it for the video. So thank you for watching. Like, share, subscribe, leave any comments, questions, suggestions down in the comment section below. If you'd like to support what I do here with actually hardcore overclocking, I have a Patreon. There's a link to that down in the description below where you can support me directly. Then there's also the AHOC Teespring store where you can pick up shirts, stickers, posters, you know, the usual YouTuber merch. There's a link to that down in the description below as well. So that is it for this video. Thanks for watching, and goodbye.